Hey guys, my name is Pablo Smith, and this is my CS5331 final project overview. This is the screen side of things. This is so you can kind of see the code a little bit cleaner than holding a phone up to the screen, just to get an idea of what's going on. On the left-hand side, here is the server, and then on the right-hand side, this is the Pi. So this server is here locally. I'm running off a Ubuntu desktop machine I have. And then on the right hand side, this is the Pi. So we could actually stop this service, go in and view this service. So I'm SSH'd on both of these windows. So I'm remotely logging into both of these guys. And there's the Python code behind that guy. And then we can go back out, kick that guy back off. And we go over here, we're going to see the code for the app. Now, natively, if you're not to do any sort of port forwarding or anything, this app would obviously only work on the local network. You have to get access to the server. So in order to solve that problem and make it kind of a true smart home system, what you can do is as I've done, make a dynamic DNS. So the public IP address of the router sometimes changes. Sometimes it doesn't. It could take 6 months. It could take a year. But dynamic DNSs allow you to set a name for that page, and you could actually go here and see. So this is smarthomettu.ddns.net. So you can get your own private and pay for one, or you could just use an extension. In this case, this is from no IP. So you can see, and this is forwarded on port 2234. So this is actually a HTML view of the server. You can actually go back and see. So here it is, JSON server. So and see all the data points on it. So the app communicates through that, and since you have a dynamic DNS link, you could use that off of the local network. So you could do that using cellular, you could use that at a coffee shop, and you could get access to the Pi here at my house. And then the nice thing about Flutter/Dart is that you write one set of codecs, and you pretty much can create an app for both iOS and Android. So you only have to write code once. So it makes it really handy, makes it a lot easier, so you only have to build it once. And yeah, so that's about it for this portion. I'm going to turn it over to the live demo. Appreciate it. Right, hey guys, this is the live demonstration of my project here. Just a quick overview of the hardware. Have a power supply, have the digital servo, have an analog servo. This runs at 5 volts, this runs at 7. Solve that issue. Buck converter, have a motor driver board, and then have the Raspberry Pi, have the Arduino Uno, and then the motor driver and the A to D are set up over I2C. And then we have a voltage sensor, and we have another voltage sensor. That just makes it so that we don't put more than 5 volts into the Pi or Arduino. In the Pi's case, it'd actually be 3.3. And then we have the white LED, blue LED. White LED will come on, blue is the interrupt. So I'm going to demonstrate that real quick here. So currently right now the Pi is actually asleep. So what I'm going to do is I'm going to say awake Arduino. Give it a second here. Those lights are going to come on. Then they will go back off. And then what I'm going to do here next is I'm actually going to plug. So right now we're reading 3.28 volts. I'm going to plug this guy in. So a future enhancement I could do is do a dynamically updating page. So right now I'm just gonna have to reload it, and you can see that voltage just goes down to 3.2. I don't have anything tied to fan 2 right now, so that's why it's reading all kind of funky readings, but you can see if you get below the halfway voltage, it says that it will be turned off. And then if we say lock door 1, you're gonna get, so that red servo there actually moved. We lock door number 2, we actually have that servo moving, and then I'm gonna unlock both of them. So I'll do that just one more time. Lock door 1, and then I'm gonna lock door 2, see it go red. Awesome. All right, I appreciate it greatly, guys. Thank you.